Hello guys, my name is Bino, and in this video we'll be going through question 2 from the April 6, 2021 N6 mathematics question paper. And question 2.1, we have to evaluate the integral of sine cube 2x into 1 minus sine squared 2x dx. And to evaluate this integral, first we have to refer to our trigonometric identities, and we have to use the formula sine squared x, which is also available on our formula sheet. Sine squared x plus cos squared x is equals to 1, but in our case we have to use it as sine squared 2x plus cos squared 2x is equals to 1. And when we make cos squared 2x the subject of the formula, this will be equals to 1 minus sine squared 2x. So in the place of 1 minus sine squared 2x, we'll substitute cos squared 2x, because cos squared 2x is equals to 1 minus sine squared 2x. So this will be equals to sine cube 2x multiplied by cos squared 2x dx. We break the sine cube 2x and we write it as sine squared 2x multiplied by sine 2x and the cos squared 2x dx. And we also have to use that trigonometric identity again. Instead of making the cos squared 2x, this time around we make sine squared 2x the subject of the formula, and this will be equals to 1 minus cos squared 2x. So in the place of this sine squared 2x, we will substitute 1 minus cos squared 2x in the place of this sine squared 2x. So our integral will be equals to 1 minus cos squared 2x multiplied by the sine 2x and the cos squared 2x dx. From here we distribute the sine 2x cos squared 2x inside the parenthesis, so 1 multiplied by that will be equals to that, and cos squared 2x multiplied by the sine 2x cos squared 2x will be equals to cos squared 2x sine 2x cos squared 2x dx, and this will be equals to sine 2x cos squared 2x. So the cos squared 2x multiplied by the cos squared 2x will be equals to cos to the power 4 2x. So the bases are the same, we add the exponents. Cos to the power 4 2x multiplied by sine 2x dx. Now we have to distribute the integral sign and the dx inside the parentheses, and this will be the integral of sine 2x cos squared 2x dx minus the integral of cos to the power 4 2x sine 2x dx. So let's write this cos squared 2x first, and this one, dx minus the integral of cos to the power 4 2x sine 2x dx. From here we have to let u equal cos 2x. We differentiate u with respect to x, so the derivative of cos is negative. So when you differentiate anything which starts with the letter c, you always get a minus. So minus sine 2x. So the 2x is the function of the function. So this cos is the function and the 2x is the function of the function, and according to the chain rule we have to also differentiate the function of the function, the 2x. So the derivative of 2x is equals to 2. So let's write that 2 and the sine 2x. So we multiply both sides by dx, and that dx will cancel out with that dx, and so du will be equals to negative 2 sine 2x dx. We can choose to make dx the subject of the formula and we substitute it there, or we can use the mirror method where we can see that we have sine 2x dx there and sine 2x dx there, but here we have sine 2x dx with this negative. So let's get rid of this negative 2. So that negative 2 will cancel out that negative 2. So du over negative 2 will be equals to sine 2x dx. So in the place of that sine 2x dx and that sine 2x dx, we will substitute du over negative 2, because du over negative 2 is equals to sine 2x dx, and in the place of cos we substitute u. So in the place of cos we substitute u, but that cos is raised to the power 2, so we also raise the u to the power 2, and in the place of sine 2x dx we substitute du over negative 2 minus the integral of, in the place of that cos we substitute u, and the cos is raised to the power 4, so we also raise the u to the power 4, and in the place of the sine 2x dx we substitute du over negative 2, because it's also equals to sine 2x dx. So this will be equals to, so we can take this 1 over negative 2 out of the integral, and we'll be left with u squared du inside the integral. So same here, we take this 1 over negative 2 out of the integral, but this negative and that negative will be positive, and inside the integral we'll be left with u to the power 4 du. So we have that negative 1 over 2 multiplied by the integral of u to the power 2, which is u to the power 3 over 3 plus 1 over 2 multiplied by the integral of u to the power 4, which is equals to u to the power 5 over 5 plus c, and our integral, we have negative 1, so the denominator 2 multiplied by the denominator 3 will be equals to 6 u to the power 3 plus the denominator 2 multiplied by the denominator 5 will be equals to 10 multiplied by u to the power 5 plus c. So our integral was in the form of dx and not the du, so let's substitute back the tan x, is it tan x? The cos 2x in the place of u. So in the place of u we substitute cos 2x, but that u is raised to the power 3, so we also raise our cos to the power 3 plus 1 over 10 multiplied by cos 2x, the u is raised to the power 5, so let's also raise our cos to the power 5 plus c. And that's it for question 2.1. If you have any questions, you can post them in the comment section below. Question 2.2, we have to evaluate the integral of tan cube 3x multiplied by sec to the power 4 3x dx. The first step is for us to break down the sec to the power 4 3x, and we write it as sec squared 3x multiplied by sec squared 3x dx. We know from our trigonometric identities and also from our formula sheet that 1 plus tan squared x is equals to sec squared x. But in our case, we have tan squared, tan of 2x squared sec of 3x, and sec squared sec 3x, sec squared 3x. So in the place of sec squared 3x, we will substitute 1 plus tan squared 3x. So our integral so we leave the first sec squared 3x, and for the second sec squared 3x, that's where we substitute 1 plus tan squared 3x, and our dx, we distribute the tan cubed 3x sec squared 3x inside the parentheses. So 1 multiplied by that will be equals to tan cube 3x sec squared 3x, and tan squared 3x multiplied by tan cube 3x sec squared 3x will be equals to tan squared 3x tan cube 3x sec squared 3x dx. The tan squared 3x multiplied by the tan cube 3x will be equals to tan to the power 5 3x. The bases are the same, so we add the exponents. Sec squared 3x dx. From here we substitute both the integral sign and the dx inside the parentheses. We distribute the integral sign and the dx inside the parentheses such that we have the integral of tan cube 3x sec squared 3x dx plus the integral of tan to the power 5 3x sec squared 3x dx. From here we let u equal tan 3x, and we differentiate u with respect to x. The derivative of tan is sec squared, and our 3x, the 3x is the function of the function, the tan is the function, and the 3x is the function of the function. And according to the chain rule, we also have to differentiate the function of the function. So the derivative of 3x is 3. We multiply both sides by dx. That dx will cancel out with that dx, and du will be equals to, we write the 3 sec squared 3x dx. We can make dx the subject of the formula and substitute it there, or we can use the mirror method where we can see that we have sec squared 3x dx here, and here we have 3 sec squared 3x dx. So we divide both sides by 3. That 3 will cancel out with that 3, and du over 3 will be equals to sec squared 3x dx. So in the place of sec squared 3x dx, we will substitute du over 3. So in the place of that sec squared 3x dx as well, we will substitute du over 3, because du over 3 is equals to sec squared 3x dx. So in the place of the tan, we substitute u. The tan is raised to the power 3, so we also raise the u to the power 3. And in the place of the sec squared 3x dx, we substitute du over 3. Like I said, you can make dx the subject of the formula from here and substitute it there. The sec squared 3x will cancel out each other, plus in the place of tan, we substitute u. The tan is raised to the power 5, so even the u, we raise it to the power 5. In the place of the sec squared 3x dx, we substitute du over 3. So this 1 over 3, we can write it out of the integral. such that inside the integral we have u to the power 3 du. Same story, we write the 1 over 3 out of the integral so that we can have u to the power 5 du inside the integral. So the integral of u to the power 3 is u to the power 4 over 4 plus our 1 over 3 multiplied by the integral of u to the power 5, which is equals to u to the power 6 over 6 plus c. The denominator 3 multiplied by the denominator 3 is equals to 12, and in the place of u, let's substitute back the tan 3x. The u is raised to the power 4, so let's raise also the tan to the power 4. The denominator 3 multiplied by the denominator 6 is equals to 18. In the place of u, we substitute back the tan 3x because u is equals to tan 3x. The u is raised to the power 6, so we also raise the tan to the power 6 and our c there. The 3, we have to evaluate the integral of x plus 1 squared multiplied by ln of x plus 1 squared dx. And the first step is for us to let u equal x plus 1. And from here we differentiate u with respect to x. The derivative of x is 1. The derivative of 1 is equals to 0. From here we can multiply both sides by dx. That dx will cancel out with that dx. And du will be equals to 1 multiplied by dx, which is dx. So from here we substitute u for the x plus 1, but the x plus 1 is raised to the power 2, so even the u we raise it to the power 2. Ln of x plus 1, for the x plus 1 we substitute u, and the x plus 1 is raised to the power 2, so even that u we raise it to the power 2. So du is equals to dx, so in the place of dx we will substitute du. So from here, to evaluate this integral, we have to use integration by parts. But before we do that, we know from our logarithmic laws that if you have ln of a to the power raised to the power b is equals to b ln a, and if we have ln of 5 raised to the power 4, this is just the same as 4 ln of 5. And in our case we have ln u squared, so ln u squared will just be the same as 2 ln u. So in the place of the ln u squared we will substitute 2 ln u. So our integral will be equals to u squared 2 ln u du, and this 2 is a constant. We can take it out of the integral for simplicity's sake, so that inside the integral we will have u squared ln u du. And to evaluate this integral we have to use integration by parts. The formula for integration by parts, we have the integral of f of x. Oh, but we are working with u, so this is going to be f of u g prime of u du. So let me write it again. So the integral of f of u g prime of u du will be equals to f of u multiplied by g of u minus the integral of g of u f prime of u du. So we have to figure out which one will be equals to f of u and which one will be equals to g prime of u between u squared and ln of u. So the u squared is an algebraic function and the ln u is a logarithmic function. And according to the ILET rule, the first one that you come across going to the right will be equals to f of u, and the other one will be equals to g prime of u. As we can see, the logarithmic L comes before the algebraic A, so the logarithmic function will be equals to f of u, and the other one will be equals to g prime of u. So we differentiate the f of u and integrate the g prime of u so that we can get g of u. So the derivative of ln u is equals to 1 over u, and the integral of u squared is equals to u to the power 3 over 3. So our integral Our 2 times the integral of u squared ln u du will be equals to these 2 into f of u multiplied by g of u. Our f of u is ln u, and the g of u is equals to u to the power 3 over 3 minus the integral of g of u multiplied by f prime of u. Our g of u is u to the power 3 over 3, and the f prime of u is equals to 1 over u du. So we have 2 times ln u to the power 3 over 3 minus, so this 1 over 3 we can take it out of the integral, so u to the power 3 over 1 over u will be equals to u squared. So this u will cancel out with one of the u's there, and we'll be left with u squared du From here, we can integrate u squared du. So the integral of u squared with respect to u is u to the power 3 over 3 plus c. From here, let's distribute the 2 inside the parentheses. So we have 2 multiplied by this 1 over 3. So we have 2 over 3 ln of u to the power 3 minus the 2 divided by this denominator 3 multiplied by that denominator 3 is equals to 9 u to the power 3 plus c. So let's take back. From here we take back. So we say that u is equals to x plus 1. So we take back the x plus 1 in the place of u. Our u square is raised to the power 3. So we also raise the x plus 1 to the power 3. And in the place of u, we take back that x plus 1. The u is raised to the power 3. Also, our x plus 1, we raise it to the power 3 plus c. And this will be our answer for question 2.3. We have to evaluate the integral of 1 over the square root of 9 over 4 minus 3x minus x squared dx. And in order for us to evaluate this integral, we have to use our formula sheet. So from our formula sheet, there are only 2 formulas which we can use. So like as we can see, the denominator has a square root, and only 2 formulas have the square root in their denominator. So we have that the first one, it has a square root. Also this last one, it also has a square root as its denominator. So we have to either use this one or that one. But before we can use that formula, so like to simplify the denominator, we have to complete the square. So we have to complete the 9 over 4 minus 3x minus x squared by square. And to complete the square, so let's write this in standard form: negative x squared minus 3x plus 9 over 4. In order for us to complete the square, we have to make sure that the coefficient of x squared is positive 1, and in this case it's negative 1. So we have to take, so we can't cancel, we can't divide through by negative 1 so that we can have a positive x squared. This is not equals to 0. This is not an equation, this is an expression. So we can only take negative as our common factor. So we'll have x squared plus 3x minus 9 over 4 after we take negative 1 as our common factor, so that the x squared can be positive. So we have x squared plus 3x. So another rule for completing the square is that we have to take the coefficient of x. So the coefficient of x is 3, and we take the coefficient of x without the sign. So if this was negative 3x, we were just gonna take the 3 without the sign. We have to divide it by 2, and we have to square the whole thing, and we have to minus this whole thing by itself, minus 9 over 4. So this expression is just the same as that one. So 3 over 2 squared minus 3 over 2 squared is equals to 0. So we didn't change that expression, we just added a 0 to it. So the other rule is that we have x squared here. We only have to take 1x, and we have to take now the sign which is here, and we have to bring it here. We have 3 over 2 squared. We don't have to take with the square. We only have to take the 3 over 2 without the square. But this x plus 3 over 2 squared, we have to square it. So this part is equals to that part without that part. So we have simplified this part, and it's equals to that. So now we are left with negative 3 over 2 squared minus 9 over 4. So 3 over 2 is equals to 9 over 4 minus 9 over 4 . So negative 9 over 4 minus 9 over 4 is equals to negative 9 over 2. So we can distribute this negative inside the parenthesis. So this negative multiplied by this positive will be negative x plus 3 over 2 squared. This negative multiplied by that negative would be positive 9 over 2. So this is equals to 9 over 4 minus 3x minus x squared. So if maybe you want to make sure that you didn't make any mistakes with any of these steps, what you can do is that you can substitute x for any number this side, and you write down what you get. Maybe if you substitute x for 9, you write the value that you will get, and you also substitute x for 9 that side. So you should be able to get the same value when you substitute x for 9 here this side, and also x for 9 that side. So this will be equals to the integral of 1 over the square root of minus x plus 3 over 2 squared plus 9 over 2 dx. So now we can refer to our formula sheet. So the first ones are positive, so b squared x squared is positive, and the a squared there is positive. So the first one which appears are positive, but we have negative as the first one which appears. So let's take that positive 9 over 2 and let's make it the first one which appears inside the square root. So we'll have 9 over 2 minus x plus 3 over 2 squared dx. From here, so we can see that the first one which is positive here is the one which has an x squared, which has a x and which is squared, but the first one which appears first does not have a square, does not have an x. So we have to use that formula and not this formula, because the x in this formula is negative, the x in this formula is negative, and the number is positive, and our number here is positive. So we use the first formula, and according to the first formula, we have to also write this in that standard form with the a squared and the b squared. So we have to write the 9 over 4 as squared. So that we have to write the 9 over 2, I mean, so the 9 over 2, we have to express it as, so 9 over 2 is equals to the square root of 9 over 2. But in order for this to be equal, we have to square. We have to square that, and this 9 over 2 will be equals to the square root of 9 is 3, and the square root of 2 is the square root of 2. squared. So our a will be equals to 3 over the square root of 2, and our b, so whatever contains x is squared. So from our formula sheet, the x squared is replaced by the x plus 3 over 2, and the number before x plus 3 over 2 is 1, so this is just the same as 1 squared. So 1b will be equals to 1. So our integral will be equals to 1 over b. Our b is equals to 1 over 1 arc sine of b, which is equals to 1. So what is squared? So whatever it is that is squared, we multiply it with that b. So we have x plus 3 over 2 over a. Our a is 3 over the square root of 2. So if you have a over b over c, this will be equals to c over b multiplied by a. So our answer will be equals to the arc sine of the square root of 2 over 3 multiplied by x plus 3 over 2 plus c, and this will be our answer for question 2.4. Question 2.5, we have to determine the integral. Question 2.5, we have to determine the integral of sine squared minus cos squared 2. Question 2.5, we have to evaluate the integral of sine squared 2x minus cos squared 2x dx. We know from our trigonometric identities and also from our formula sheet that cos 2x is equals to cos squared x minus sine squared x. So on the left hand side, the x is double, and on the right hand side, we only have a single x. So if we had cos 4x, then this will be equals to cos squared 2x minus sine squared 2x. We have 4 times the x, and here we have half the x than we have on the left hand side. So our 2.5, we are starting with sine squared instead of starting with cos squared. So the sine is positive, but here the sine is negative. So we have to manipulate our integral so that it can match what we have here. So to do that, we have to take negative as our common factor so that the cos squared 2x can be positive and the sine squared 2x can be negative. Then from here, cos squared 2x minus sine squared 2x will be equals to cos 4x dx. So the integral of cos 4x dx will be equals to sine 4x over 4. So we divide by 4 when we integrate, but if we were differentiating, we were gonna divide by the integral, by the derivative of the function of the function. So the function of the function is 4x. If we were differentiating, we are going to multiply by the function of the function, but in this case we are integrating, so we are dividing by the derivative of the function which is 4x